All right, so for mechanical strength of material, excuse me, um, essentially the base of everything here are loads. Okay, and so there's various ways that loads are applied to different members. And so here we're talking about tension, compression, bending, shear, and torsion. And pretty much all these we're going to be touching up on little by little as we go through the slides, and that includes refresher and of course the workshop. Now, one thing I like to do just to kind of exaggerate a little bit, uh, to show what's happening when we're dealing with each case here is I like to draw. And so if we look at tension, we have these arrows that are, of course, pointing up here and down there. And what's going to happen with this member is that eventually, we're going to have some necking in the middle. We're going to have an expansion, right, of the overall length of this member. For compression, of course, that's the opposite. And we're going to have something like that. For bending, in this case, we'd be doing something like this. And again, these are exaggerated, of course. For shear, we could think of just, scissors. And we're just going to cut right there. We're going to have that split. And then for torsion, of course, that's applying some sort of twist, right? So this is going to be a little hard to do, but that's pretty much what you're going to see when you're dealing with torsion. For loads, once they are applied to a member at a particular area, we have what we call stress. And as I've already described, stress just refers to a force or a load that's going to be applied to a cross-sectional area. Now we have various types. Here we have normal stress and shear stress. With normal, the force is going to be normal to the particular area, and shear is going to be parallel. There's various ways that stress can be expressed. So obviously it's important that while you are taking the exam, you are paying attention to the units, whether the units in the problem itself or the units in the answer choices. Pay attention, all right, because it's very, very easy to mess up. Page 131 of 10.0.1 reference handbook, we see what we're supposed to be using to calculate stress. Again, it's that load divided by the cross-sectional area. Here you see load as P. So you could see F force, L for load, P for load as well. And you could see those in other problems or other equations. So you have to make sure that you're paying attention to the actual letter and what's actually being used. All right, so you don't confuse yourself.